All right, this is part 2 for our Unit 11 test review. I am picking up on number 4. You'll notice that 4 is already in factored form, so we didn't have to do the procedure that takes us from standard form to factored form. It's already like that. So it's already in simplified form because none of the factors cancel, so there's also not any holes. R is for roots. Set the factors from the numerator equal to 0 and solve. So that gives me 8, 0 and negative 2, 0 for roots. A is for vertical asymptote, so set your denominator equal to 0 and solve. X equals 3. T is for tangent over together. None of these factors are squared, so this is a no situation. E is for end behavior. I need to compare my leading terms together. That means I need to multiply these first two terms to know what my leading term is in the numerator. So it's x squared on top, x squared on bottom. That is a top-heavy situation, which means I have an oblique or slanted asymptote. So it's going to be not vertical or horizontal, but it's going to be at an angle. So I have to find the linear equation for that asymptote, the y equals mx plus b. I do that by dividing the numerator by denominator. In order to do that, I need the standard form for the numerator, so I'm just going to FOIL this out. So it's the first terms are x squared, the middle are negative 8x, positive 2x, so negative 6x, and then the last term's negative 8 times 2 is negative 16. And then it's x minus 3 on the bottom. You can do polynomial long division. I'm going to do synthetic division. So I take the 0 of the denominator, which is 3, and the coefficients of the numerator, 1, negative 6, negative 16. Drop the first term down, multiply these two things together, that's 3. Add this way, that's negative 3. And I don't need to finish it, I only need these first two values for my linear equation. So that's 1x minus 3. So graphing that, I'm going to use the intercepts. When x is 0, y is negative 3. And when y is 0, x is positive 3. So 0, negative 3, 3, 0 right there. And that is my slanted asymptote. So my y-intercept is where I plug 0 for all the x's. Doesn't matter which form you use. You can use factored form. You could use standard form. I like standard form. So I'm going to put 0 for all these x's. Gives me negative 16 over negative 3, which is a plus situation. So I have 0, 16 thirds, which is 0, 5 and a third. So I'm going to graph that. So our curved shape is going to be going through these 2 points, approaching the vertical asymptote there and the slanted asymptote down there, and then mirrored in this section over here, passing through this root. Like that. So as x goes towards the vertical asymptote, y is getting closer there, and as x goes to positive infinity, it's approaching the slanted asymptote there. All right, for this bottom graph, Again, we are already in factored form. No common factors top and bottom, so it doesn't simplify. There's no holes. For the root, I'm going to set the numerator equal to 0. Why this is different from this very first problem is because this one had no variable, so there was no solution to solve for, and this one does. So setting the numerator equal to 0 and solving gives me 0. Also, if your x-intercept is 0, 0, your y-intercept is also 0, 0. So if you just were to plug 0 for all these x's, you'd have 0 in the numerator. So any 0 divided by anything is 0. Just for the record, you can't divide by 0, but we're not going to have that in this situation. All right, vertical asymptote, we set the individual factors equal to 0. So this is going to give me x equals -4. X minus 3 solved is x equals 3. Leave those in equation form. T is for tangent over together. There's nothing tangent in the there's nothing squared in the numerator. There is a factor squared in the denominator. So it's no on top, yes on bottom, and that yes on bottom means that the graph pieces are going to come together at the asymptote for the squared factor, and that asymptote was x equals 3. Now remember, we're just going to let that information hang out there till we need it when we're drawing. And then E is for end behavior. So my leading term on top is the only term, 3x. Now the denominator, I need it to be standard form before I know what my leading term is. So you don't have to FOIL and expand all of that. You just need the first terms. So I have x here times x squared here. So x from that one, x squared for that one, and it's x cubed. So that is a bottom heavy situation, which means my asymptote is automatically y equals 0 for my horizontal asymptote. Okay, so now I am going to start graphing my pieces. This has 3 pieces. There's no slant asymptote. We know that the ends are going to be shaped like this somehow, some version of this, either in one of these 4 different directions here. And my middle piece is going to be some version of x squared or some version of x cubed for this middle piece. So we need more information to figure that out. I have a root, but it could be bouncing here, it could be crossing through. So I need to do a test point. So I'm going to pick an easy number. I'm just going to pick x equals 1. So test x equals 1. So I'm just going to take that 1 and put it in wherever I see an x in my original function. So that gives me a 3 on top, 5 on bottom in the first factor, and a -2 squared for the second. That is going to give me 4 times 5. That is 3 over 20. So my test point is 1,320. I don't really need to know what this exact value is. I really only care that it is positive, because at 1 I'm going to have this really small value here, and that is enough to know. Oh, and I also know that because this root factor is not squared, it's not going to be tangent, it's going to cross through. So this is enough to know that this is my shape. Okay. If this x had been squared, it would be tangent at that root and going back up this way. And now that I know this is my middle shape, I can piece the other 2 together by looking at my asymptote information. I know that it's coming together at x equals 3, which means it's going the same direction on either side. So here's that asymptote. So here would be that curve. And it is not together at the other asymptote. So it's not coming together, it's going apart. So it's going away. So it's right, down, it's going to be left, up. And for the last problem. So this was accidentally blank, even though I wrote this space left intentionally blank on my PDF because I thought that was funny because they do that in books sometimes, this page left intentionally blank. Of course, when you have to explain a joke, it's not funny, I understand. Okay, for this last one, we are going to use the given graph information to write an equation. Start with your roots. We have roots at x equals -3, -1, 2. None of those are tangent, so there won't be any squared factors in my equation. I have vertical asymptotes at x equals -4 and 3, here and here. The behavior on either side is not together, so none of those factors will be squared. And I'm given a point at 5, 4, which I will plug in for x and y when I try to solve for my a. So here's my general equation. I'm going to create factors from these by taking their opposite signs. So that's all my root information, my asymptote information, x plus 4, x minus 3. None of these are squared because they don't have the corresponding behavior. So now I'm plugging in the 5 for all my x's and the 4 for my y. Simplifying all those parentheses. And you can multiply across the top and across the bottom here if you'd like. I'm going to simplify it, this step right here. Let's see. 6 divided by 2 is 3. 3 times 3 is 9, and there's a 9 on the bottom, so I'm going to cancel all those. And I'm left with just an a on top. 8a equals 4. Divide both sides by 8, and a equals 1/2. So I just need to go back to my general form, plug in 1/2 for a. I like to do that like this. The numerator here, the denominator there. Of course, we don't have to leave our 1, so it's 1, which I'm not going to write, so it's implied. Or I'll just write it so you can see it, 1. And then the 2 on the bottom. There we go. Done.